In this video, we are going to solve a system of linear equations using the substitution strategy. So now that we've looked at the substitution method, we're now going to look at situations where we can solve real-world problems utilizing substitution. So in this word problem, it says many businesses pay website hosting companies to store and maintain files that make up their website. Company A charges a setup fee of $10 and then charges $21 per month, while Company B charges a setup fee of $0 but has a monthly fee of $22.45. Find when the two companies will cost the same. So that's ultimately what I am trying to find in this problem, is when they cost the same. So I'm noticing here that I have two unknown things in my problem. The first thing that's unknown is the when. It says find when. And I notice in here that I have months as an important piece of this. So X is going to stand for my number of months, because I need to find after how many months these two companies will in fact cost the same. Then from here, the other thing I don't know is the cost. I don't know what their cost is when they are the same. So my other variable is going to be cost. So here it says write two equations about the situation, one for each company. So I'm going to write an equation for Company A, and I'm going to calculate cost. And so remember, my cost is calculated by a setup fee of $10 and $21 per month. So in order to calculate my cost, I know that up front I'm going to have to pay $10. But I only have to pay this $10 once. And after I pay this $10 once, I then have to pay 21.95 times the number of months that I've had that site. So that's going to be 21.95 times X, or you can just write 21.95 X. So that's how my cost is calculated. So here I have $10 plus 21.95 times the number of months, and that is going to equal my cost. So here I've written a cost equation for Company A. It's $10 as a flat fee plus $21.95 per month. Then I need to write an equation for Company B. And Company B calculates its cost a little bit differently. So here I have cost is equal to a $0 fee up front plus $22.45 per month. So now we have a cost equation for each company. And now we're going to utilize substitution in order to help us find when these two costs are the same. And remember, our first step in substitution is to get a variable alone. And if we look here, each equation actually already has a variable by itself. So just the way that we've written our equations, we've already set it up great for substitution as is. Now what we're going to do is we're going to substitute the value of one y in for another. So I'm going to take what y is equal to in this first equation. Remember, an equal sign means that each side has the same value. So y and 10 plus 21.95x are both the exact same value. And what we're going to do is we're going to replace what y is equal to in for the other y value. Remember, we're trying to find when our costs are equal. So we're going to set the cost equation for each situation equal to each other. So now if we replace the y in the second equation with 10 plus 21.95x, we'll have 10 plus 21.95x is equal to 0 plus 22.45x. So we've now set those two cost equations equal. Now we want to solve for the value for x when this is occurring. So we subtract 21.95x from each side. So I end up with 10 is equal to 0.50x. Divide both sides by 0.5. And I find that x is equal to 20. And remember, x is our number of months, so x is equal to 20 months. So what I found here is that at 20 months, both of these costs will be exactly the same. So now if I want to find out what that cost is, what I can do is I can take the 20 months, I can substitute it back into either of these situations. So here, if I take the first situation and I want to find my cost at 20 months for each company, we have y equals 10 plus 21.95, and I'm going to replace x with 20 because that is what x is equal to when these two companies have the same cost. So now if I multiply 21.95 times 20, I end up with 439. And I then add $10 to it, and I find that the cost at 20 months for both of these companies is $449. So what I can conclude in this situation is that both A and B will cost $449 at 20 months. So this word problem states that the volleyball team is selling candy bars and bags of popcorn at the tournament this weekend. The volleyball team sells twice as many candy bars as bags of popcorn. They sold candy bars for $2 each and bags of popcorn for $3 each and sold a total of $175 worth of food. So we're trying to figure out how many candy bars we sold and how many bags of popcorn we sold. That's what we don't know in this situation. So what we're going to do is we're going to assign those to be variables. I'm going to assign x to be the number of candy bars and y to be the number of popcorns we sell. So that's what we're ultimately trying to find. Now, the one equation that I can see in here for sure is I can see that I have a cost equation. I can see that I sold candy bars for $2 each and bags of popcorn for $3 each. So in order to calculate my cost, it would be 2x plus 3y is equal to a total in sales of $175. So that equation in blue represents my cost situation. Now the second equation here is a little bit more difficult to see, and it actually stems from this detail in the second sentence, where it says that the volleyball team sells twice as many candy bars as bags of popcorn. So if I start to break this down, twice as many candy bars means that I sold more candy bars. That's the first thing I need to remember. And what I'm noticing is that with however many candy bars I sold, it is 2 times as many as the popcorn. Or, however many popcorns I sell, I'm going to take that, multiply it by 2 to make it twice as many, and that's how many candy bars I sold. Now, if I think about this in terms of variables, I notice that my popcorn is represented by y. So this is really y times 2 is equal to my number of candy bars, which is represented by x. So my second equation here is really going to be x is equal to, so my candy bars are equal to 2 times the amount of popcorn that I sell. So there now is my second equation. Now, part 2 says to solve this using substitution. And the reason that substitution is a great strategy here is because we already have a variable alone here in our second equation. So what we're going to do is we're going to take what x is equal to, and we're going to substitute it into the other equation in place of x. Because x and 2 times y have the same value per that equal sign that is between them. So if I rewrite the first equation, I have 2 times, I'm going to replace x with 2y, plus the 3y that I'm leaving alone is equal to 175. So now what I can do is I have an equation with one variable. So now I can actually work through and solve this. Now notice that this parenthesis doesn't have a plus sign or a minus sign in it, so this is just really 2 times 2, which is 4 times y, plus the 3y I notice that I have like terms on the same side of the equation. So I have 7y is equal to 175. Divide both sides by 7, and I find that y is equal to 25. Now I have to think about this for a second. Remember, y represents popcorn. So I sold 25 bags of popcorn. But remember, we have two values that we need to know from this problem. So if I think back and I realize, okay, I have 25 popcorns, let's use one of these original equations to help us determine how many candy bars we actually sold. Well, I notice this second equation is really easy. This is where it's stating, okay, I sold twice as many candy bars as popcorn. So I can take my popcorn, which is 25, multiply it by 2, and I find that I sold 50 candy bars. So in order to fit both constraints of this problem, where I sell twice as many candy bars as bags of popcorn, and at the prices they're set at, I made a profit of $175, I would sell 50 candy bars and 25 bags of popcorn.